mode of transmission is what it's carried on. And portal of entry is how it gets in you. And susceptible host is the fact that our weak or our people who are more susceptible are going to be more at risk. And there's also people called super spreaders, people who carry the virus, have no signs and symptoms, but are just spreading it all over the place. So and that applies to not just viruses, that applies to bacteria, that applies to anything, that we're talking about as far as microbiology, okay? So, and this is going through each one of those. So it says that, and you can come back if you'd like, and you can take notes with this, but the reservoir host, like I was just saying, it's what hosts the agent. Usually, only human and animals are host, but at rare times, plants can be as well. Now that portal of exit, that is where the microorganism leaves the host. All right, it's now the host that it's in, them two might have a really good relationship and no problem, and it's not sick or anything, but it leaves that person or that animal or that whatever, and now it's exited. So that could be through a nose, mouth, sneezing, coughing, feces, sex, anything, okay? The mode of transmission, all right? So, and these kind of intertwine, and I know some of them seem like they're very closely related. Mode of transmitting, a lot of times this is through waste products of the infected person, all right? A route by which an organism can be transferred. This could be direct or indirect, like walking through a sneeze. That's an indirect contact. Direct contact is shaking hands, right? So it can be direct or indirect. Bless you. My son gave you an example of a sneeze. Portal of entry. This is the site where the microorganism enters into the host, right? And this could be a cut in your skin that's microscopic. This could be through your eye. It could be through something you breathed. It could be through something you ate. So it's the portal at which it enters into you. Susceptible hosts. This means anything that is easily invaded, okay? And humans, we're easily invaded. But when we like to also add to this and think about our immunocompromised elderly babies. We throw that into this as well. But a susceptible host could be anyone, okay, or anything. So it is what receives it. Usually how things work are we don't usually, we're not able to give our animals our pathogens, but there are a lot of pathogens that we can get from certain animals. So it gets more complex as you move along in microbiology. But all you need to know now is keeping it real simple that the susceptible host, it can be anything, but we also want to make sure we think about our elderly and immunocompromised and so forth. All right. All right, let's talk about infectious agents. All right, an infectious agent pretty much can be anything, okay? Oh, what did I do? Oh, no, that's right. It could be bacteria, it could be viruses, it could be protozoa, it could be fungi, parasitic, so whatever's causing the infection. Incubation period. Now, this is something I want you to write down and I want you to know, okay? Oh, poop, my emails are still on. Incubation means the time at which you've become exposed to the pathogen infection, between that and the time your first symptom appears. What do we know? How long is the incubation period for COVID? 7 to 14 days, right? Believe it or not, I'm going to make this really easy for you. Most viruses are 7 to 14 days. So it's kind of cool. So it makes it easy. Almost all of our viruses are like that. Could somebody get it within a day or 2 days? Yeah. Are there some viruses out there that are so scary, like Ebola, that you get it and within 24 hours you're dead? Yes. Their incubation, they don't have an incubation period. It is get, die, gone. So, and that's how the length of that time varies on what pathogen or infectious agent, and I use those terms interchangeably, okay, that you're exposed to. All right. Now, the thing to remember with microbiology and infection control and the immune system, they're all so tied together. And the reason is because what might make me sick may not even cause you a single symptom or an issue. Every single human is different. And every single human has a different incubation period. Okay. And so, like I said, we give it a generalized time frame. 7 to 14 days is usually. Now, everybody should know this because I've talked about this before. When we say that something is acute, this means that, and you do need to know this. If you don't know this, like automatically, oh, I know what acute is, then write this down. Acute means that this is a disease, or this is an infection, or this is something that comes on very suddenly, usually hits us kind of hard, but goes away. Okay? So the flu, cold, bronchitis, different things, okay? So we think of those all along the lines because it's a rapid onset, out of nowhere kind of thing. So it's acute. And acute affections, depending if they're bacterial or viral, is going to depend whether they need antibiotics or not. Because do we treat viral infections with antibiotics? No. No, we do not. They're not effective. But we can treat a bacterial infection with antibiotics. So, and we talked about how they are using antivirals more, but we usually try to reserve those for the people who are at real risk and their bodies are more prone to infection, and let the healthy people let their immune systems fight it off, because that's what's best for the body. Now, a chronic infection, and if you automatically, that definition just didn't pop up into your brain, then write this down, because chronic means something that comes on usually slow and develops and continues to develop and stays with you, usually for a lifetime, or comes and goes, comes and goes, comes and goes. All right. And we see this a lot with like chronic hepatitis. COPD is a chronic disease because you'll have the effects of the smoking cigarettes and everything that stays with you. What else is chronic? There's so many, and my brain's just gone blank. Certain kidney diseases can be chronic, and certain infections can be chronic. Certain types of cancers can be chronic. There's something called chronic myeloid leukemia, and it's you get abnormal cells, but usually they're able to control it, and you can go in and have treatment because of how slow it moves, and it's something that you're able to live with, but it's still a leukemia, right? And it does, diabetes type 1 is a chronic infection. So it means you've developed it and you're going to stay with it. And all of these are this way until we find a cure, till we are able to end that. That's what chronic means, is that it's long term, there's nothing we have. We can treat the symptoms, we can make the patient feel better, but we're not going to be able to cure. All right. Now, latent, this one you may not be familiar with. Latent is, I like to think of them as the little sneaky ones, because they usually come along. Sometimes they get inside and you don't even know that you're sick. What they do is they'll cause a little flare up initially. I'll give you the perfect example. Syphilis is a latent infection. So syphilis comes along. You've had sex, and we talked about. I think we did reproduction. I can't remember. You get a little canker sore, and that could be anywhere on the body. You may not even realize you had it, and it's gone. And then you might feel a little tired, but then the virus just goes and chills. It goes latent or dormant. HIV does this as well. A lot of viruses do this. They come along and they invade, and then they lay dormant and wait and build forces. And as they become stronger and stronger as those forces build, and they end up becoming very, very hard to treat and get rid of. They can also, it doesn't have to be just viral. Bacteria, they can be bacteria as well, like tuberculosis. Tuberculosis is a latent infection. You could get infected with TB and then not really have any signs or symptoms for quite some time. And then when you get your immune system gets knocked down a bit, that's when a lot of times we start seeing the signs and symptoms, or if you're under a great amount of stress or something like that. Now, opportunistic infections, these are, my micro teacher called them the a-holes of micro. They're the OIs. They're the ones that basically prey on people who are, and it's not like they have a conscience or something, but they're the type of pathogen that we're not going to see a healthy person get. We're not going to see somebody with an intact immune system. The perfect example I can give you is, I mentioned my uncle had HIV way back in the beginning of the HIV epidemic, and he had a parrot. His parrot got a fungal infection on its little talon, and he ended up contracting that fungal infection, and it went to his brain, and that's what ended up killing him. So that would be an opportunistic infection, because that's not going to be something that's going to, harm a healthy human being with an immune system. Our immune system wouldn't even let that, in or bother us. But because people who have a weakened immune system or immunocompromised, undergoing chemo, radiation, that kind of thing, they are extremely sensitive, like myself. That's why I'm here at the house, because you got these little opportunistic infections, and you imagine picking that up or something like that along with COVID or something, and probably be like, sayonara, see you later, Miss S, and we don't want that. All right, This is another term that you may or may not remember me mentioning, but if you do not know it, I want you to write it down. It's called a no-synomial. And basically, here's a whole bunch of words, and I'll give you the great examples. Fast and easy. Mama breaks her hip, falls, breaks her hip. She goes into the hospital. She has her hip surgery. She comes out great. She's smiling, sitting up in bed, and then a few days later, she ain't doing so good. The doctor's like, oh, she got pneumonia. Well, she got the pneumonia in the hospital. Or maybe she falls, she broke her hip, and she didn't get pneumonia, she got an infection in the wound. That infection in the wound was got in the hospital. So any type of infection that a person acquires, not the reason they're necessarily that they went to the hospital, but they acquire it in the hospital, is called no-synomial infections, and they are killers. Because I always say a broken hip, so many times you see old people go in broken hips, they don't come back out. And it's because of pneumonia. It's because that hospitals are not a clean place. Hospitals are not someplace that you want to be. And that's why they try to get you, if you are sick and you are in the hospital, get you in and get you out and get you well as soon as possible. Another really common no-synomial infection cause is because of UTI, like Foley catheters. The area wasn't cleaned properly. We see these. I have a real issue with nursing homes. And if you'd have worked as long as I have as a paramedic, you would too. And no-synomial infections are so rampant in nursing homes, and it's because of lack of care, abuse, neglect. And so that's something that we do see fairly often in nursing homes, long care term facilities, that sort of stuff. All right, so we're going to move on. And remember, you can always go back and take the notes that you need to. The inflammatory response. I showed y'all a video, and hopefully y'all watched it. Do you need help with that? Okay. The inflammatory response is when our body, like I was mentioning yesterday, our skin's really amazing. Even if it's something internal, our skin will tell us, hey, something's not right. We might get a little, like you break a bone. What's the first thing that happens? It starts swelling. And that's the inflammatory response. That's the body's way of telling you, we're going to war. We're going to fix something. We're going to fight something. And I always refer to this as sort of like an army scenario. So there's a lot of, sorry for that. There's a lot of major components I'm going to leave out of this, because as an MA, it's just not necessary to put all of it on you. If you go and you move on, like into nursing or decide to go to pre-med or med school or something like that, you're going to know. You'll learn all about this. But everything as far as the inflammatory response is done by chemicals that we call like histamines. And I know you've heard of that because you take an antihistamine, which is like Benadryl, right? Bradykinin and prostaglandins, different things like this. There's just all these chemicals. So whenever something is cut, like we cut our hand, and like I have a cut right here. And so when I first cut it, it was red, and you can still see the little area around it was red, but it was a mild inflammatory response. So my immune system was set the alarm off, and depending, and so it sent a few people to take care of putting the tissue back together, regenerating and healing and causing that scabbing process and that kind of stuff. But initially, when we see the inflammatory response, and I said this yesterday, this is not going to be pertinent to you because this is from an old text. But the signs and the symptoms, and you have to know these, all right, are pain, swelling, it may feel warm, and redness. The area will be red. And the redder it is, the more swollen it is, the hotter it is to the touch. It means that the body's working and it's not able to maybe win this battle. It's kind of losing. So that's why a lot of times we go into the doctor and we get antibiotics and we get something to help our body win that battle. The prevention, well, our greatest prevention is our skin. And I said that yesterday. But we also have our gastrointestinal, the GI tract, because our stomach contains, which we know contains hydrochloric.
It's not always.
Oh, does it?
I get it's blamed, but no, that's better. It's not under the skin like it was last time.
Okay, it's a little deeper.
Yeah,
Sub-Q is a 45.
Yeah.
Okay.
It's
My daughter's giving herself her migraine injection.
Yeah, like last time you could clearly see the outline of the bubble. You know that this one is like,
deeper. Okay. Yeah. Just make sure when you do, 45 degree. Okay. You did good. Okay. I'm proud of you.
Because you're a great teacher.
Okay. Sorry. Our stomach, like I said, it has hydrochloric acid. Hydrochloric acid's like you put a drop of it on a car, it'll leach straight through it. So, but in the stomach, it does its job. So that's another way. Our mucous membranes and our filtering that we have. So we have lots of things inside of us, but our greatest protection is our skin. All right. And a lot of times we know things get past that, like with the flu and the cold and stuff like that, or cuts get infected, and sometimes that happens. And then we have our lymphatic system. And our lymphatic system, you're going to hear a lot of people try to separate and pull the lymphatic and the immune apart. I like to mesh them together because me personally, I believe that one can't exist without the other. All right. And I'm going to explain why. The lymphatic system, I think of it as, close your eyes, like imagine a human body with just all of the blood vessels. And you can, how they trace everywhere and they go all the way out from up into the head and the neck and down the arms and the fingers and legs and toes. They're everywhere. So that's our circulatory system highway. Well, our lymphatic system has its own highway, and it very much mimics the way that the cardiovascular does as well, because it has little highways and byways that go throughout the whole body. And it has fluid, just like, cardiovascular has blood. Well, the lymphatic system has something called lymph. And at this lymph, and that's this right here. Lymph actually contains white blood cells, which are part of your immune system. That's why I said these got to go hand in hand. And one of the things that I want you to get into the habit of realizing is when you see this WBC, that means white blood cell. All right. So that'll help you with phlebotomy. So go ahead and write it down and know it now. But our WBCs are military. They are the fighters, they are the protectors, and there's multiple kinds, and we're going to talk about that. And they have reign over the whole body in a healthy person. But in a normal healthy person who's not under any kind of attack they kind of chill. And where they like to chill is the lymph nodes. And I'll show you some pictures of where lymph nodes are. Now, there's always some kind of swimming around and floating and on guard, right? But our lymph nodes are an area where they can like a rest stop along the highway. One of the first actions that the white blood cell does, those little guards that are floating around, they see anything come along that looks wrong, it looks shady to it, it's automatically going to do something called phagocytosis. And that's what this word is. And you can write it down and next to it put equals Pac-Man, because that's exactly what it does. The phagocytosis is these white blood cells, and there's a specific one, they see the bacteria, they take it and they engulf it. They swallow it, they break it down, and they make an antibody. All right? And so the next time, hopefully the body will be remembering. We'll get to that later. That's a little more in depth. But I do need you to know that term, that phagocytosis is Pac-Man. It's where the white blood cells go around hunting and looking for anything that shouldn't be there. And they're chomping and engulfing and swallowing it up. All right? Nobody's got questions so far? Y'all are real quiet.
No, ma'am.
Okay, all right. So, we're at 30 minutes. Let's see if I want to start. Do I want to start? No, antibodies are pretty in depth. So let's leave it at the lymphatic. Now, what I am going to do is I've got 3 videos that I really, 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 really want y'all to watch. And if you watch them, when we start talking about antibodies and stuff, it'll make it so much easier to understand. Because let me see something real quick here. Let me go to Teams. And I'm looking. I don't think I've posted the video I want yet. And I love how y'all are responding to these. This is excellent. This immune system was really, I don't know, can y'all see my screen that shows the immune system? This little video?
No.
No, ma'am.
Okay,
No.
1 second. Let me show you this. Well, poop. Can y'all see all the names?
Yeah.
Okay, cool. All right. So this video right here. Have y'all watched this?
No.
Watch it. It's excellent. Okay. And then and this is the other one that I want y'all to watch, okay? And then
No problem.
I've got 2 more that I'm going to post for y'all. If you haven't done your Survey Monkey, go ahead, please make sure you get that turned in. And I've got I'm going to try to get y'all's project put up for the mod, okay?
Okay.
Any questions?
Nope.
I have a question.
Yeah.
Sorry. So do you want us, even though we were in listening here, do we still have to write down the 3 facts?
You do not. If you were here, you were actively involved in the call and the lecture. No. But if you are online lab, you have to respond to everything that says like this. If you always have to respond here.
I have a question about that.
Okay.
I see everyone else posting like long stuff, and I'm like, wait, should we be doing that? I thought, because normally I just put that I watched the video and I understand. But do I need to like type what I learned from the video?
That would be helpful. Like type in and tell me like one thing that you learned.
Okay.
That yeah, something like that. Yeah. So it gives me more because the more interactive you are with that, the
Yeah.
more it lets me know you understood it.
Okay.
All right. All right, guys. Y'all have a wonderful day,
You too.
and we'll see you tomorrow.
Bye.
Bye.